Here's a geometry slash trig puzzle that was kind of fun to solve. I had a lot of fun trying to figure this out. You could think of it as just a simple geometry problem, or you could think of it as a fun outdoorsy puzzle. You could use this if you ever need to get the height of something or the distance to something. So here we have line segment BD. We don't know how long that is. We do know the distance between AC, and we know the angles alpha and gamma. I've used this particular math equation before when I wanted to get the height of a tower, just out of curiosity, but the tower had a big fence around it. I think it was just like a cell phone tower. And I used an equation similar to this when I wanted to hang up a big rope swing over a really high branch. But in that case, I could walk directly up to the tree and pace off the distance between D and A, and then just use a tangent function to get the height of a segment BD. Just remember, if you use trig in the real world to get the height of something, be sure and add an additional 5 feet because that's about how high your eyes are off the ground. So in this example here, line segment AD would be a straight line from your eye to the tower or the cliff face. So you add an additional 5 feet below you or below that to account for the height from the ground up to your eyes. I used to live outside the city, and in my backyard there was a huge tree with a huge branch that was up really high, maybe about 30 feet or so. So I needed to get the height of that branch so I could throw a rope around it and use it for a rope swing. The branch was so high, what I needed to do was I tied some fishing line to an arrow, and then I used my recurve bow, shot the fishing line over the branch, and then attached paracord to the fishing line, and then attached the rope swing rope to the paracord, and then I was able to pull the rope over. I found out if you attach the fishing line directly to the big rope, then the rope is so big it'll snag on the branch and you'll keep breaking your fishing line. So in order to get the height of this branch, I was able to actually walk all the way up to the tree and then just pace off the distance between the tree and some other location, and then use the tangent function to get the height of the branch. I'll explain in a little bit how you can get these angles in the real world. This was a situation where the branch was so high that I had the potential to massively overestimate the amount of rope that I would need. Then I would have just wasted a lot of money on extra rope. And then of course, if the rope was too short, then I'd have to buy extra rope and tie knots in it to tie the ropes together. And I didn't want a bunch of knots in the rope. Okay, so as for this situation though, you're not able to actually walk up to the tree or the tower or the cliff face. So we can make a story out of this, and this kind of math could actually save your life someday. Let's say you're out camping in a van down by the river with some friends, and line segment CD is where the river is, and then line segment BD is the cliff face. And your friend thinks that cliff face is only about 30 or 40 feet high, so he wants to climb up there and jump into a deep section of the river or the lake. But you're thinking it might be a little closer to 60 or 70 feet high, which would be a little too high to jump from, considering the water depth and whatnot, even if your friend is an experienced cliff jumper. So you don't have any rope with you, so you guys can't just climb up the cliff and throw some rope down and then pace off the length of the rope. But you do have your smartphones with you that have the leveling apps on them that tell you angles and how much you're tilting the phone. And then also, let's say maybe in your backpack you also happen to have a protractor, so you can tie a string to this protractor with a weight on it, and then you can look over the top of that protractor and use that string and weight as a plumb bob and find out what the angle is. But if all you have is your cell phone, you can just use the leveling app on your cell phone and hold the cell phone up to your eyes just above your nose, and look across the top of your cell phone to the top of that cliff right there, and then have someone look at the number on your cell phone to find out roughly what that angle is. It's not exact, but it'll get you pretty close. Thus, we can pace off line segment AC, and we can either use our phones or a protractor to get the angle alpha and gamma. So how to use this information to get the height of the cliff face, which is the line segment BD. You can pause the video if you want to try to figure it out for yourself. Otherwise, I'll show what I got on the next page. I think it's kind of fun presenting these problems as puzzles so people can try to solve them if they want to, instead of just teaching it like a normal class where you just give all the answers right away. Okay, on the next page, I'll show how to solve it. All right, so here's the answer. By the way, I don't remember how long it took me to solve this problem. I was thinking it was a few hours or maybe even a day or two. It was one of these problems where it just felt like there was an answer or it was solvable, even though there's a lot of unknown variables. But somehow I was able to put everything together the right way. Okay, so I'll just start here. Line segment AC plus CD will equal AD right there. We know AC, we don't know CD. Let's go ahead and solve for CD. So that's going to be AD minus AC will equal CD. So let's see what these two triangles have in common. We have triangle ABD and then a triangle CBD. They both share line segment BD. Thus, both triangles have a common line segment, meaning that line segment is in both triangles. So we can use that line segment BD as a connector to connect the larger triangle with the smaller triangle. So we got tan alpha right here. That's going to equal BD over AD. But then what I'm going to go ahead and do is skip a step and just say that tan alpha equals BD over AC plus CD. I just found that out with trial and error. Now we solve for BD because that will be the common connector between our two triangles. So we have a line segment. Actually, what I did here is two steps at once. I'm going to bring up the AC plus CD, and then I'm going to distribute that tan alpha through both at the same time. So I get tan alpha times AC plus CD tan alpha equals BD. So now I've solved for BD as the common connector between our two triangles. Now we have tan gamma is going to equal line segments BD over CD. And let's go ahead and solve for line segment BD because that will be our common connector between both triangles. So we have line segment CD times tan gamma will equal line segment BD. So here, this equation and this equation both equal BD. So let's just put them together and make this equal this. We have line segment CD tan gamma will equal line segment AC tan alpha plus CD times tan alpha. Actually, I'll go ahead and show that right here. I just took this equation and set it equal to that equation. Now let's look for common factors that we can combine. We have a CD on both sides of the equation. Let's bring this CD tan alpha over to the other side. We have CD tan gamma minus CD tan alpha equals line segment AC times tan alpha. We can pull out our CDs, and then we have line segment AC tan alpha over the quantity tan gamma minus tan alpha, and that will equal line segment CD. Notice in this equation that CD is the only unknown. AC is measured, and then tan alpha and tan gamma are both measured. Now that we've solved for line segment CD, we can just use the tangent function right here. Tan gamma will equal BD over CD. We solve for BD. Now we know the height of our cliff. And if you wanted to, you could also solve for line segment CB, which is the hypotenuse. And that's just what I showed right there. On the next page, I'll show a similar problem, but the angles will be different. By the way, this will also work if you're looking down at the ground from a bird's eye view. And say you have a person on at location A and a person at location C, and they're on hilltops, and there's either smoke or a flare or something out here at location B, and you want to get the exact distance to location B. But I'll cover that scenario on the next page. Here's another way this math problem could save your life or prevent injury if we want to keep this on an outdoorsy theme. Let's say while you guys are all out camping, some of your friends decide to go out hiking in the woods. But let's say that they are inexperienced hikers, so they placed too much importance on their handheld GPS. So they didn't bring a compass with them, and they didn't look at a map first to see where they'd be going. But then after they get out in the woods, the batteries on their GPS go dead. And of course, they're outside of cell phone range, so they can't just use the navigation on their cell phone to find their way back. So let's say just for safety, they happen to have a flare gun with a single flare and a walkie-talkie. So they radio back to you and tell you that they are stuck and have no idea where they are. So with that one flare, they're like Eminem. They got one shot, one opportunity. So you and your friends are going to have to figure out a way to find out exactly where they are with that one flare. Let's say you're an experienced outdoorsman, so you happen to have a map of the area, and you know there are two large treeless hills nearby each other. And you can either use your map to get the approximate distance between those two hills, or one of you could just jump in your car and drive to a nearby town where you have cell phone service and use Google Maps to drop a pin on one of these hills right here and find out how far it is to the other hill, roughly. Granted, on Google Maps, I think those lines follow the terrain instead of just making a straight path through the air. But if you did use the Google Maps, that would give you at least a rough idea of how far apart those two hills are from each other. By the way, whenever you go out hiking in the woods, even if you have a GPS device or your phone, always bring a compass because the batteries won't go dead on those. And always look at a map first before you leave your car so you know exactly where you're going and you know in which direction the highways and creeks are. So if for some reason your GPS batteries go dead or something, or your GPS stops working, or if you're using your cell phone and you lose cell phone service, you can always just use your compass and find your way back to the whichever road is around you. So in this situation here, let's say one friend climbs up one hill and has his compass, you climb up another hill with your compass, and you radio back to your friends to find an opening in the canopy of the trees so they can shoot up their flare and you guys can see it. So he shoots up a flare, and then both of you look at your compass and tell exactly in which direction that flare is. So if your friend does happen to have a compass with them but no GPS, you could radio back to your friend and tell him his exact direction and which direction he needs to go to get back to the campsite or the road. So if your friend's direction is at 340 degrees, or you could say north 20 degrees to the west, then that means he needs to head exactly 160 degrees, which would be south 20 degrees to the east. But if he doesn't have a compass, that means you just need to walk out and get him. So you need to know that exact distance or pretty close to that exact distance so you'll know not to walk past him. In case as you're walking along, you might end up walking past him if you guys don't see each other, if there's a lot of dense forest or something. And then, of course, worst case scenario, if there's an injury or something and you have to call in a helicopter to that exact location. And you could say for the story that maybe your friend is even less prepared and he doesn't even have a walkie-talkie. He just has that flare gun with one shot. So you guys could have an agreement where if he gets lost, then exactly at 7 p.m. he could shoot up that flare and then you guys will know where he is. So there's different ways to write this story. This would also work if you had two fire towers at location A and C, and you had some smoke at location B, so you could use this math here to get that exact location. In real life, I imagine people that man fire towers would have maps of the area, so then they could just lay out a couple of straight edges on their map, and wherever those straight edges cross will be the location of the smoke. So the math is similar, but not the same. We still have line segment BD as the connecting line between the two triangles. And we'll say that line segment AC is known because that's the distance between the two hills. And angles alpha and gamma are known because you use your compass to point in the direction where location B is. We go through the same math to find the line segments here. So line segment AD plus DC equals line segment AC. Go ahead and solve for DC here. Tan alpha equals BD over AD, BD over AD, and then we solve for BD. We do the same thing with tan gamma. Right here we solve for BD. So CD tan gamma equals BD, and next page. Both of these equations equal line segment BD, so that means we can set these two equations equal to each other. And here I said CD tan gamma will equal AD tan alpha. I made a little bit of an error here, but it still works. I reversed the letters, so instead of line segment CD, I said line segment DC, but I'll leave it in there. Those little imperfections just add a little bit more of a challenge. So line segment CD or DC, whatever you want to call it, DC here, CD there, equals AC minus AD, right there, tan gamma. Go ahead and distribute that tan gamma through. Look for common variables. We have AD on both sides of the equation, so let's bring this AD tan gamma over to the other side, and it looks like this. Then we can go ahead and pull out our ADs right here. Then we can have line segment AC tan gamma divided by the quantity tan alpha plus tan gamma. And that is what this looks like right here. And I just wrote here we have an unknown, which is AD equals a known divided by known plus known. So now that we've solved for AD, we can take tan alpha right here equals BD divided by AD right there. So AD tan alpha equals line segment BD, which is right there.